Okay, so in this video, I want to continue evaluating a function, but this time I want to sort of talk through and think through what would it mean to evaluate a function for a non-numerical value. So for starters, what if I wanted to evaluate this function for some other variable like h? And I'm picking h for calculus-y reasons, but I don't want to explain why we use h in calculus. I'll just save that for when you're actually in calculus. Okay, I just wanted you to know it wasn't just some arbitrary letter that I pulled out of my hat. Okay, so if I want to evaluate this thing for f of h, then I'm going to do the same thing with that h that I would do with a number. I'm going to take it and I'm going to plug it into my function everywhere there's an x. So we're just going to do a replacement. So to prepare, I'm going to build the skeleton of what my function does, how my function receives its input. So I might mentally put parentheses around my x's here so that I see my input where x goes. That thing is going to be squared plus 12 times whatever my input is, minus 10. That's what my function does to the input. So this time, what is my input? Everywhere there's an x, I replace that with an h, and so I get that. So then the next step is simplify as much as I can, and simplify just means, for the most part, get rid of parentheses, combine like terms. So if I think through this really quickly, what does it mean when I square h? Well, I just multiply h times h, and I get h squared. I just don't need those parentheses. Likewise, what does it mean here to multiply 12 times h together? Well, 12 times h is just that, 12h. So plus 12h, bring down that minus 10. I've gotten rid of my parentheses. Are there any like terms to combine? Nope. So what is f of h? F of h is just this. And if you compare it to the regular function, or the original function, it appears all I did is change the letters. And that's true. In this particular case, the only thing that changed were the letters. But on the next case, what happens if I want to evaluate the function for not just h, but x plus h? And again, I'm doing that for calculus-y reasons that will be clear someday in the future. So again, I'm going to set up my skeleton. What does my function do to the input? Well, it squares it here, and then it multiplies that input by 12, and then it subtracts 10. So what's my input? My input is x plus h and x plus h. So this time, now when we want to simplify as much as possible by getting rid of parentheses and combining like terms, I'm going to have to remember some things. It's not trivial this time to get rid of these parentheses nor these parentheses. These parentheses exist because I'm squaring whatever's on the inside. These parentheses exist because I'm multiplying by this 12. So let's start with the easy one. We recall that we're going to have to distribute that 12 to get rid of those parentheses over that addition. So I'm going to leave that for you to do in just a moment. But the classic mistake a student makes here, we've talked about in another video. Because I've got addition or subtraction inside here, because I've got two terms, or more than just multiplication, when I square, it's not as simple as just square the x and square the h. I'm going to have to recall that that is something that needs to be FOILed out. So what I'm going to encourage you to do is, in a moment, pause the video and on scratch paper or somewhere, multiply out x plus h times x plus h, combine your like terms, and then show me what you get right there. Okay, I'm going to pause it, and you should pause it too. And when you're ready, unpause, and I'll keep going. Okay, so hopefully you got x squared plus 2xh plus h squared when you finished multiplying x plus h times x plus h. If you didn't, go with me on this for now. I want to finish simplifying this problem, and when we're done with this, on the next slide, I'll demonstrate how I got x squared plus 2xh plus h squared. Okay, but let's continue. So I squared this binomial to get this. Like we said before, I'm going to have to distribute that 12. Let's do that quickly. Plus 12 times x is 12x, plus 12 times h is 12h, minus that 10. So we've successfully gotten rid of parentheses. And let's inspect, do I have any common, or any like terms? So I'm just going to start here and work my way to the right. And if I do this carefully enough, I only have to focus on the terms that follow, and I don't have to look forwards and backwards for like terms. Okay, so what I mean is, I'm going to start with x squared, and I'm going to look for, are there any other x squareds? So looking to the right, nope. Nope, those are h squareds, not x squareds. These are x's, but not x squareds. Nope, nope. So there are no other x squareds. Okay, so I know that, sorry, I'm having a mental moment. Let's just leave this for now. I have these 1x squareds and no others. So then I go on to the 2xh. So in order to be a like term, I have to have the same variables with the same exponents. So I need any other like term to have both an x to the first power and an h to the first power. And I know that the x squared doesn't because I already considered that when I went the first time through. So I only need to consider the terms to the right. That's what I meant earlier. So I'm going to look. I have h squareds, but not h's and not x's. I have x's, but not h's. Vice versa. Definitely not like terms with the 2xh. So then I move on to the h squared. Do I have any other h squared terms? Nope, nope, nope. I don't have to worry about these guys. I've already considered them. Moving on to the 12x. Do I have any other x terms? Regular old x terms to the right? Nope, nope. They have all been considered. So no like terms to go with the 12x. 12h, like terms? Nope. Constant term, any other? No. So it turned out, once I foiled this mess out and distributed this 12, I ended up with this, and this is the simplified form of all of this right here. Okay? So if you want to see how did I come up with this x squared plus 2x plus h squared, I'll do that. But let me finish by saying, what is f of x plus h in this particular problem? It's all of these gruesome terms, which we'll have more fun with some other day. Okay, so carrying on. If you're happy and satisfied, this is essentially the end of the video. You can stop it now, unless you want to see where did x squared plus 2xh plus h squared come from. Here we go. Here are my foiling steps. When I multiply this x times that x, I get my x squared. When I multiply this x times that h, I get just that, an xh. When I multiply this h times that x, I get an h times x, which I could call hx, but I'm going to go ahead and note that xh and hx have the same variables and the same exponents, so I'm just going to be consistent, and since I wrote my x's first here, when I multiply these together and get hx, I'm going to write it in that same order, plus another xh. And then finally, this h times that h is an h squared. Then I'd like to see, do I have any like terms? As we've alluded, I do right here. So I've got that 1x squared. I have 1xh plus another xh. So how many xh's is that? Well, it's 2 xh's. And then plus h squared, okay? If for some reason in your own notes, you had written this as x squared plus 2hx, plus h squared. I want to acknowledge that that's equally true and correct, and there's no rhyme or reason to why I wrote mine the way I did, other than, I guess, in the original, x's came first and then h's, but there's nothing incorrect about this whatsoever. Excuse me. Hiccup. There's nothing incorrect about this whatsoever. We could have equally used it, okay? But that's more or less the end of that thought. Adios.